Hi class, this is Dr. O'Connor. We're going to talk about ethers, thiols, and alkyl halides in this video. So let's first take a look at ethers. Ethers are compounds that have two organic groups bonded to the same oxygen. So here we see the oxygen. In this case here we have two methyl groups bonded to the oxygen. So in the common naming system, we name ethers by identifying the two alkyl groups or organic groups that are bonded to the oxygen and then just add the word ether. So for example, this one here has two methyl groups bonded to the oxygen. We would call this dimethyl ether. This one here has a methyl group and an ethyl group bonded to the oxygen. Ethyl has alphabetical priority. This would be ethyl methyl ether. This one here has two ethyl groups bonded to the oxygen. We would call this diethyl ether. In this case, I will hold you responsible for the common naming. Now, let's go up here and we'll learn how to name ethers using the IUPAC naming system. But first, we're going to look at these cyclic ethers, and we're going to come across these later when we get into the biochemistry. Many ethers have the oxygen in the ring. This one here would be ethylene oxide. This is tetrahydrofuran. This is a solvent. And this here would be 1,4-dioxane, which is a solvent. So you don't have to memorize these, but just keep in mind that there are cyclic ethers that we're going to work with a little bit later in the semester. And this is what they look like. You can think of this one here, for example, as being a pentane, a cyclopentane, but one of the carbons is replaced by an oxygen. Same here. This would be a cyclohexane, but two of the carbons are replaced by oxygen. So this makes this a cyclic ether. Now, let's talk about the alkoxy group. An alkoxy group is an oxygen bonded to an alkyl group or an organic group. So for example, this part of a molecule, the O and the methyl group here, would be called a methoxy group. This has two carbons, and this would be an ethoxy group. We could do propoxy groups, isopropoxy groups, and so on. These are used in the IUPAC naming system, and also when the ether functional group is present with other functional groups. So let's just take a look at a couple of examples here. Okay, let's do this one. Okay, so the common name for this would be ethyl methyl ether, but we want to name this using the IUPAC system. So what you do is select the longest continuous carbon chain, and you would go ahead and name that with the corresponding alkane, and then you change the YL ending of the alkyl group, in this case a methyl group, to OXY, and that gives us the alkoxy name. Okay, so here we have 1, 2, this is an ethane, okay, and this would be called methoxyethane. All right, so we have the methoxy group here, and then this here is our longest continuous chain, and so this would be called methoxyethane. Okay, let's go ahead and try another one. Here we have two ethyl groups bonded to the oxygen. Chain length is the same for both, so we would call this an ethane. And here we have the ethoxy group. So this would be called ethoxy ethane. And this is one word, by the way. Okay. And the same here. This is one word. Let's do this one here. We'll do one more. And so we'll do this OCH. And let's put a methyl group right here. So this one here, our longest chain is 1, 2, 3, 4. We have 4 carbons, okay? And so this would be a butane. And then this is a methoxy group, okay? And in the case of the butane, we have to indicate the carbon number that the methoxy group is attached to. So we're going to go ahead and number this way. 1, 2, 3, 4. You're going to have a 1 methoxy, and then there's a methyl group on carbon number 2. So this is going to be a 1 methoxy, 2 methyl butane. So 1 methoxy, 2. I'm going to have to erase this because, okay. So 2 methyl butane. Again, all one word. Okay, so practice naming the ethers. Now, here's an example where there would be another functional group present. So in this case here, we have this OH group. So we can name this then as an alcohol. So here we would have ethanol, and then on carbon number 2, because the OH group here would have priority, on carbon number 2 we have an ethoxy group. So this would be 2-ethoxyethanol. Let's do another one here. You haven't seen this before, this Me. That would be a methyl group. And sometimes you'll see this, an ET. That would be an ethyl group. So here, what we have is a methoxy group, okay? And this is a benzene ring with an OH, so it is a phenol. And we have methoxy group, which is ortho to the OH group. So this would be ortho methoxy phenol. So just practice naming these and you should be fine. Again, I do want you to know how to name them both using a common system and the IUPAC system. Now, in your chapter, they talk about the Williamson synthesis of ethers. I am not going to hold you responsible for that, so I will not ask you anything about that. But I do want you to know some of the properties of the ethers. Ethers contain polar carbon-oxygen bonds. Well, we know the carbon-oxygen bond is polar. Smaller ethers are higher boiling than alkanes that have similar molecular weights, but lower boiling than alcohols. And this is because ethers cannot hydrogen bond with one another. So, for example, let's look at this ether here. So we have this dimethyl ether, and it's the lone pair of electrons. There is no hydrogen bonded to an oxygen, fluorine, or a nitrogen. So they cannot hydrogen bond with one another. No intermolecular hydrogen bonding. So that makes them lower boiling than similar molecular weight alcohols. On the other hand, ethers could hydrogen bond with water molecules, and that makes the small ethers water soluble. So small ethers are water soluble, up to about 3 carbons, okay? Like alcohols, ethers with large organic groups are not water soluble. That is because they become more hydrocarbon-like. Now, ethers are not very exciting compounds. They really don't react with acids, bases, or other reagents. They're not very reactive. On the other hand, they will readily react with oxygen. So we have to be careful when we store these ethers. Small ethers are very flammable, and ethers can form explosive peroxides when they're exposed to air. And these peroxides contain this oxygen single bond. So we have to store them in absence of oxygen. So we have special containers that we store these ethers in. So we have storage conditions, especially for ethers. We have to keep them away from air. And years ago, diethyl ether was used as an anesthetic, but we usually use it today as a solvent in the lab. So that's it as far as ethers go. Again, you don't need to know how they are synthesized. So now we're going to look at thiols and disulfides. So a thiol has this general formula, and we refer to these as sulfur analogs of alcohols, because remember, an alcohol can look like this. The thiol has a sulfur in place of the oxygen. Thiols are also called mercaptans, and we name thiols by adding thiol to the parent hydrocarbon name. So we name them like alcohols, but instead of OL, we use the thiol suffix. So here we have a 2-carbon thiol. This would be ethane thiol. Okay. Remember, if this was an OH here, that would be ethanol. In this case, it's ethane thiol. And we don't drop the E in the ethane. This one here, again, the thiol group is going to take priority when numbering. So we would number this way: 1, 2, 3, 4. So we have a butane thiol, and the thiol group is on carbon 1, so 1 butane thiol. And on carbon number 3, we have a methyl group, 3-methyl, 1 butane thiol. Here we have 2 thiol groups, so we want to name this just like we do the dialcohols, where the thiol groups have the lowest possible number. So in this case here, 1 thiol is on number 1, 2, 3, 4, and 5. So we have a thiol group on carbon 1 and 1 on number 4. And our longest continuous chain is a pentane. So we have a pentane. Now we use the prefix di because we have 2 thiol groups. So pentane dithiol. And these thiol groups are on carbon 1 and carbon 4. So 1,4 pentane dithiol. Make sure you practice naming these. And as far as thiols go, they all have very strong odors. For example, the skunk odor, that's due to thiols. Garlic, that's very strong. It also contains thiol. Onions as well. And also natural gas. I'll talk about that in a second. So skunk scent is caused by 3-methyl-1-butane thiol and 2-butene-1-thiol. So why don't you try drawing these structures when you can. Draw the structures that correspond to these thiol names. Natural gas has no odor at all, but we can smell natural gas, right? And the reason we can is because it's treated with methane thiol. Okay, that's what gives natural gas the odor. Otherwise, we would not be able to tell when there is a gas leak in the home or around the home. Thiols react with mild oxidizing agents, and they react in water with a mild oxidizing agent to produce a disulfide. We're going to be talking about disulfides when we get into the biochemistry portion. For now, I want you to know this reaction. Basically, you have 2 thiols that join together to form a disulfide. This is a disulfide. You have a sulfur-sulfur single bond. So, for example, here we start off with 2 molecules of methane thiol, and again, a mild oxidizing agent. And what's going to happen is the hydrogen from each of the thiol molecules is lost. It'll combine with an oxygen to form water, and a bond will form between the 2 sulfur atoms. So we have gone from a thiol to a disulfide. This happens to be dimethyl disulfide. So we look at this. You're asked, what disulfide would you expect from the oxidation of propane thiol? So what I like to do is I go ahead and write out the formula here for the 2 molecules of propane thiol, and it's these hydrogens here that will be lost, and then the bond is going to form between the 2 sulfurs here in order to form dipropyl disulfide. So make sure that you can recognize the reaction for the oxidation of a thiol. Okay, so next here we're going to talk about halogen-containing compounds, and we've already come across those in previous chapters. So the alkyl halides, they have this general formula here, where X is a chlorine, a bromine, a iodine. So it's a halogen. X is a halogen. So when we name these using the common naming system, we give the name of the alkyl group followed by the halogen name that has an "ide" ending. So for example, here we have a methyl group, and chlorine is bonded to that carbon. So this would be methyl chloride. As far as the IUPAC naming system, we find the longest chain, name the parent alkane, and then we give the halogen substituent name as a prefix. So this one here, we have 3 carbons, and we have a chlorine that's on carbon number 1. So we would name this as 1-chloropropane. Here we have a carbon with 3 chlorines, and this would be called trichloromethane. The common name is chloroform. Here we have one that's a little more complicated. So we would go ahead and start numbering, and we have 1, 2, 3, 4, 5, 6, and we have the bromine on carbon 2, the methyl group on carbon 5, so this would be a 2-bromo 5-methyl hexane. Ethyl chloride is used as a topical anesthetic, and what it does is when you put that on your skin, it'll cool it through very rapid evaporation. So these are very volatile compounds. Chloroform, that was once used as an anesthetic and also as a solvent for cough syrup and medicines. Today, we don't use them because they're considered too toxic for cough syrups and medicine. They were used in the production of Freon, which was found in refrigerators, and also pesticides and dyes. I'm just going to go over some of the more common compounds that contain halogens. The only compound that's really significant biologically is this one here, and this is called thyroxine. And this is a hormone, actually, that's secreted by the thyroid gland. But notice here, you have these 2 benzene rings, okay? And you have these 4 iodine substituents, okay? So this is thyroxine. I would expect you to recognize this one because it does have the 4 iodines. But let's go ahead and look at some of the functional groups that are present in thyroxine. Okay, so I see an ether group. Okay, so that would be right here. We have the oxygen bonded to 2 carbons, so we see an ether group. And of course we have the aromatic rings, or the benzene rings. Okay, and here we have the benzene with the OH, so we also see a phenol. And if we look at this over here, we have this carboxyl group. Okay, so carboxyl group. And here we have an amino group. So thyroxine has quite a few different functional groups in it. But again, this is the main compound that contains a halogen that is important biologically. This bromotrifluoromethane, this is actually used to extinguish fires where there are a lot of electronics. So for example, in an aircraft, and that's because it's not flammable, it's not toxic, and it evaporates very quickly, leaving no residue on the electronics, which of course could damage the electronics. The other one you might have heard of is DDT, and this is an insecticide. It is now banned in the US, but notice the chlorine substituents here. And so yeah, even though it's banned at the time, this was a great discovery because it was responsible for the eradication of both typhoid and malaria. A couple of other compounds that contain halogens. Here's one, 2,4-dichlorophenoxyacetic acid. This is an herbicide, so it's used to control weeds. So this is the structure right here. Notice the 2 chlorines. I also see an ether group here and a carboxyl group, and of course the benzene ring. And then we have another one, Captan, and this is a fungicide. It's used to control fungus diseases in plants and such. This is the structure here. We have these 2 rings here. We have the carbonyl groups, and of course the halogen atoms, the 3 chlorines. This is it for this video. I know this one is short compared to the other one, but make sure that you read your text and eliminate the sections that I talked to you about in the videos. And if you have any questions, let me know. In the meantime, have a great day.